Okay, so page 182, number 20, that we didn't have time to go over today. So a solo Arctic adventurer pulls a string of two toboggans of supplies across a level snowy ground. The toboggans have masses of 95 and 55 kilograms. Applying a force of 165 newtons causes the toboggans to accelerate at 0.61 meters per second squared. So there's a forward force here of 165 kilograms, and we're told that the whole system accelerates at 0.61 meters per second squared. Okay, and so the first question wants to know the frictional force. So you're going to do it on the whole system. I'll do it up here. So on system, and the mass of the whole system is 150 kilograms, 95 and 55. Pulling forward is F, which is 165, and pulling backward is the friction of the whole system that we're looking for. So do sum of the forces is equal to M total A, and it'll be F minus friction is equal to M total A. You're solving for friction, so bring this over, bring this over. So in the end, friction will be equal to F minus M total A. F is 165 newtons. Who put kilograms there? M is 150 kilograms for real this time, and A is 0.61 meters per second squared. And so when you do this, you get the friction on the whole system to be 73.5 newtons. Okay? That's on the whole system. But now part B says, find the tension in the rope attached to the second, though a 55 kilogram toboggan. So on number 2. So here's my second toboggan, 55 kgs. Pulling forward is the tension that we're looking for, and pulling back is the friction on number 2. Now the friction on number 2 is not 73.5 newtons. That's on the whole system. So you need to find the friction on 2, and to do that, we're going to need to find the coefficient of friction. Okay, so this is the friction of the total. So we can find the coefficient of the total by doing FFR is equal to mu Fn. So mu will be equal to the friction that we just found, the 73, divided by the normal force of the total. And the normal force of the total should just be equal to M total G, because it's not moving in the y direction. So 73.5 newtons divided by 150 kilograms times 9.81 meters per second squared, right? Because really what I did here was some of the forces in the y direction. Goes to 0, there's Fn going up, Fg going down, so Fn will equal Fg will equal M total, because we're doing it for the system, G. And so I have M total G down here. Okay, and when I do this, I get 150 times 9.81, and I'm going to divide that into 73.5. And you should get 0.049949 for your coefficient. Okay, that coefficient isn't going to change now when we come over here. So we can now find our frictional force on number 2. Doing the sum of the forces in the y direction, toboggan 2 is not moving in the y, so it'll be Fn2 minus Fg2 equals 0. So Fn2 will equal M2G. And so then friction on number 2 will equal mu M2G, which if you would like, you can find. Mu we found to be that 0.049949. M2 is 55 kilograms, and G is 9.81 meters per second squared. And so I'll get my friction on number 2 to be times 55 times 9.81, 26.95 newtons. When we look at the total, it makes sense, right? because 55 is significantly less than 95, 26, 73, it's less than half. It's about a third, and this is about a third of the total. So now we go to sum of the forces in the X. And so in the X on number 2, we have the tension pulling forward, the friction on 2 that we just found pulling back, and that should be equal to M2A. So F tension should be equal to M2A plus the friction that we just found. So tension should be equal to 55 kilograms times 0.61 meters per second squared plus 26.95 newtons. F tension should equal, so plus 55 times 0.61, you should get 60.5 newtons. Okay, now if you want to check it, you would look at number 1. So you would do on number 1. And on number 1, pulling forward is the force they told us, 165 newtons. Pulling back will be the tension that we just found and the friction on number 1 that we don't have yet. This is 95 kilograms. So we would have to find the friction on number 1. Doing the sum of the forces in the y direction equals M1A. It goes to 0. It will be Fn1 minus Fg1 will equal 0. So Fn1 will equal Fg1 will equal M1G. And so friction on number 1 will equal mu M1G. So friction on number 1 will equal, our mu was what, 0.049949. M1 is 95 kilograms, G 9.81 meters per second squared. Friction on number 1, we call 1 times 95 times 9.81 is 46.55 newtons. Now, just before we go any further, we can check this because we had friction on 2 was 26.95, so that's 27, 66, 73.50. Lo and behold, that's what the friction on the total system was. So we know we haven't screwed up yet. So now we go to sum of the forces in the x direction. And in the x direction, we have the F pulling forward. We have the tension that we found pulling backward. We have the friction that we found pulling backward equal to M1A. So 165 newtons minus the 60.5 newtons that we found above minus the 46.55 newtons we just found should equal 95 kilograms times 0.61 meters per second squared. Okay, so 165 and then minus 60.5. I think you get on this side 57.95 newtons. And now when we go to the other side, 95 times 0.61, lo and behold, you get 57.95 newtons. We did not screw up. It works. Okay, so there's number 20. Not really anything new, just a few more steps in it. Okay, but you can do some of the forces in the y and some of the forces in the x. I know you can.